Here we have a problem on derivative. So there is a function that is y equals to 2 to the power x square, and we have to find dy over dx. That is we have to find the derivative of this function with respect to x. Actually, when I consider the stuff on the right side of the given function, the base over here is a constant and the exponent is variable. But the variable is having exponent too. So that's a little trouble for me to get derivative of this function. So because if I have a function in the form a to the x power, so here the base is a, the exponent is just a variable x. So whenever I want to find derivative of a function like this, its derivative is a to the x power times ln a. So when I just have x as the exponent, I can find derivative of an exponential function easily. So the problem here is at the exponent, the variable x is having exponent 2. So if instead of x square, if I just have x, I can get derivative of this one easily. That is, for example, let us consider 2 to the x power. What is its derivative? So this is similar to this one. Instead of the constant a, we have constant 2 over here. So what's its derivative? So 2 to the x power times ln 2. So in the result over here, I just replace the constant a by the constant we have at the base over here. So the trouble what we have over here is having exponent 2 for the variable at the exponent. So what do we have to do for that? What I'm going to do is to avoid this trouble, I'm just going to assign a new variable for this x square. That is let t is equal to x square. Okay, then the given function becomes what? Y equals to 2 to the power t. Okay, as we have discussed over here, now we have a constant at the base, and we just have a variable t at the exponent. Okay, and also we know that t is equal to x square. Okay, now y is a function of t and t is a function of x. Okay, our aim is to find the derivative of y with respect to x. That is dy over dx we have to find. But can I find the derivative of the function over here with respect to x? No, it's not possible, because here y is not a function of x, y is a function of t. So we can find the derivative of this y with respect to t because y is a function of t. So I can write dy over dt. Further, so this t is a function of x. So I can find the derivative of this t with respect to x. Then I'm getting dt over dx. Actually, this is called chain rule in derivative. So our aim is to find dy over dx. So, but initially we cannot find the derivative of the function over here with respect to x, because here y is a function of t. So I got the derivative of y with respect to t, that is dy over dt. Further, t is a function of x, so I got dt over dx. So here I started with dy in numerator and I ended with dx in denominator over here. Okay, now we can replace this y by the stuff which is equivalent to y, that is 2 to the tth power. So dy over dx equals to d of, and we can plug in 2 to the power t for this y over dt times d of, and for this t we know that x square, so we can plug in x square for this t over dx. Okay, so dy over dx equals to, okay, so here just now we discussed that the derivative of a to the x power with respect to x is a to the x power times ln a. So here we have similar stuff, 2 to the tth power. So we have to find the derivative of this 2 to the tth power with respect to t. What is its derivative? So 2 to the tth power times ln 2. Okay, what is the derivative of this x square with respect to x? It's just 2x. Okay, so dy over dx equals to, t is the variable taken by us. It has to be replaced by the original stuff, that is x square. Now we can replace this t by x square. Then I'm getting 2 to the power x square times ln 2 times 2x. Here, three quantities are multiplied. So 2 to the power x square, ln 2, and 2x. So here, for these two terms, we have the same base 2. And for these two, we have the exponent x square. And for these two, we don't have exponent, and we have to assume there is exponent 1. So since these two terms are the same base, we can combine these two terms. Okay, let me do it. So dy over dx equals to, so when I combine, whenever I multiply two terms with the same base, what I can do is I can take the base ones and I can add the exponents. So then I'm getting x square positive 1 times, I can write this x over here, then times ln 2. So now I got the derivative of the given function with respect to x.